Welcome to PaperCam. We're going to talk about multiplying and dividing exponents, but understanding how to do that from nothing. So if you look in a textbook, they'll show you the rules, but what I want you to be able to do is cook up the rules yourself, just from knowing what an exponent is, right? So all an exponent is an abbreviation, very much like this, incorporated, right? Or like IBM stands for something else, International Business Machines. So when you see something like 6 to the 5, what is this? It is shorthand for multiplying 6 times itself 5 times. That's all that this is. You know exactly what this is. Just 6 multiplied 1, 2, 3, 4, 5. You know what that is. I'm not saying you know the answer, but you know what this is. This is 6 multiplied by itself 5 times. That's all this is. It's just a shorter way to write it, right? Somebody got bored writing this and he decided, hey, I can write something less ink. Here it is. So, suppose you now have 6 to the 5th times 6 to the 3rd. Okay, so we already have 6 to the 5th right here. I'll just write it again, 6 to the 5th. And then times, all right, times 6 to the 3rd. And so we just know this is shorthand for 3 of them, right? And so what is this now? Well, this is 6 times itself, some number of times. Well, how can we get that number? Well, we can just count them. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so that's 6 times itself 8 times 6 to the 8. There's the little shorthand way to write it. Now, it's going to get old fast doing it this way because look, I already know how many 6's are in this clump. 5. That's what this means. I already know how many 6's are in this clump. 3. That's what this means. So when I add these, all I'm doing is adding these, getting 6 to the 8. So we didn't have to look anything up in a book. We didn't have to find the chart of the rules or the laws of exponents. You just know an exponent is just a shorthand way of writing repeated multiplication. And if I put 2 repeated multiplications next to each other, all I'm doing is adding up all the things that I'm multiplying and then putting the number up there. But because I already know what's in the 2 groups, I can just add those 2 numbers and save myself the time. And there's my answer. Let's move on to division. So I always like to do maths kind of not remembering rules, just understanding what I'm doing. So here we're going to play the same game, even though you might already know the rule. Pretend you don't for a minute, and let's see if we can figure out what's going on. So I'm going to write this out because I know this is a shorthand for 6 multiplied times itself 5 times. This is a shorthand for 6 multiplied times itself 3 times. Now I'm looking at this ugly thing. What do I do? In the back of my head, I'm hearing this, someone saying, canceling, canceling, but canceling is sort of like, canceling, what is that? There's just some rule that I can cancel sometimes, x squared plus y squared over x squared. Can I cancel here? Why or why not? I don't know. I'll have to look up the rule. So we're not interested in that. I don't want to look up rules. I don't want to remember rules. I want to know what's going on at every step of the way. So let's take a look here. What I see is some number down here. I don't know what this equals, but I know that it's the same as this, right? 6 times 6 times 6 equals 6 times 6 times 6. So if I have a fraction with the same thing on the top and the bottom, what does that equal? Don't try to remember a rule. Let's figure it out. So let's do it with 1/2. Or 2/2, but we'll start with 1/2. So if I have 1/2, that thing tells me what I'm cutting it into, and that tells me how many of them I'm getting, right? And we can all agree this is 1/2 of the pie, right? So if I go, oh wait, no, actually, I'll give me 2/2 of the pie. Oh, well then, 2/2 of the pie, that'd be the whole pie. What if I do that with 3/3? I say, okay, well, give me 1/3. Give me 2/3. Oh, give me 3/3. Oh, you took the whole pie again. So we could play this all day. You want to do 6 times 6, 36, however many that is. All right, perfectly. And then I'll take all of them. And so this is just 1. So let's rewrite it. 1 times the thing that's left there, 6 times 6, right? And so I see that I took away the ones that were on the top and the bottom. So I subtracted the 3. This 3 that was on the bottom got subtracted from the ones on the top. You can see they're the ones that are left. And so if I didn't want to look in a book or forgot or whatever it is, I did not need to. Just by understanding what these things are, what an exponent is, and then looking at this fraction, I can remind myself what this all means and end up with this. So this one equals 6 to the 2. And if you really want to, you could take this knowledge and turn it into the rules. So this one would turn into classic x to the m times x to the n equals x to the m times n, m plus n. So I just want to point out I said this wrong first, but because of just doing this, the understanding kicked in and was like, no, that's not what's going on. You're adding them. Okay? So this is pretty vital. And now on this case here, x to the m over x to the n equals x m minus n. And we know how this works. We just saw this got subtracted from that, and so these all went away, and we got the leftovers on top. And that's how you get the multiplication and division rules for exponents out of nothing.